Good morning, everyone. My name is KG1. Today, my subject is Engineering Geology. Today, my topic failures, mechanics, and slope factors for a footing resting on slopes. Introduction to failure mechanics on sloped ground. Foundation on slopes are subjected to unique failures mechanics due to the inclined the ground surface. Understanding this failure modes in crucial for designing safe and stable footings. This presentation explores the failure mechanics and the influence of slope factors and footing stability. In the main first introduction, the footings understanding and is the failure and it give designing safe and stability footings. Basic concepts of slope stability. Slope stability refers to the ability of a to slope to resist failure under its own weight and external loads. Factors such as soil property, slope, angle, and water content influence stability. Failures can be rotational, translation, or compound in nature. In slope stability means in a soil properties, slope, angle, and water quantity is the stability. In failures can be rotational or translation or compound in nature. Types of foundation failures on slopes. Common failure types including sliding, overturning, hand bearing capacity failure. In foundation failures is common failure in sliding or overturning is a main is bearing capacity is failure. Slope condition significantly affect the likelihood and mode of failure. Proper assignment helps in mitigating potential risk associated with each failure mode. Mechanics of footing failure on slopes. Failure mechanics involves the analysis of soil structure in interactions under inclined ground condition. Shear failures occurs when soil shear strength is existed along a potential failure surface. Bending and sliding a critical consideration of footings on slopes. The role of soil properties. Soil corrosion, internal friction angle, and density influence the failure mechanics. Soft or loose soil increasing the risk of sliding and bearing capacity failures. Accurate the soil testing is essential for reliable failure analysis. In main, the soil testing is essential. The hard soil or rock, weak seam failure pain. Soft or loose soil increasing the risk of sliding and bearing capacity is failure. Slope angle and its impact. Stepper slopes generally decreasing the stability of footing resting on them. The critical slope angle depends on soil type and moisture conditions. Stability improves with generally slopes are additionally reinforcement measurements. Slope factors in foundation designing. Slope factors including the slope, inclination, soil type, and water condition. These factors modify the effective stress and shear strength at the footing interface. Engineers interpret these factors to ensure safety migrants in designing. Types of slope failures. There are main four types of failures which are plane failures, edge failures, topping failures, rotational failures. You observe the foundation design, they give an example. Types of failures. So, reinforcement techniques, reinforcement methods including retaining walls, soil, nails, and anchors. These techniques and the overall stability and reducing failure risk. Proper designing and placement are essential for effective slope stabilization. Effective of water on slope stability. Water interfiltration, reducing soil sharing and increasing overwater pressure. Shattered slopes are more prone to failure, especially during heavy rainfalls. Drainage control it virtual to maintain slope stability or footing safely. Analytic method for failure prediction. Limit equilibrium methods are commonly used to excessive slope stability. Finite elements analyze provide detailed insight into failure mechanics. This method help to designing approximated magnetism measures factors affecting flow factors safely factors. The safely factor is influenced by soil properties, slope angle, and external loads. AI safely factors indicates a more stable slope conditions. Quotes specific minimum safety factors for various slope and footing configurations. Designing considerations for footings on slope. Foundation should be designed to account for potential sliding and overturning. Used to reinforce concrete or deep foundation can improve stability. Proper site investigation and slope assignment a critical before construction. And design consideration of for footing slopes. The main use reinforced concrete or deep foundation they can improve and stability. Proper site visit and the assignment the before construction any buildings are planning. Case studies and practical examples. Several fields cases demonstrate the importance of slope factors in footing stability. Failures often result from inadequate assignment of slope mechanics. Lesson learned the need for comprehensive geotechnical analysis. You observe in last slide designing consideration for footing on slopes. Foundation should be designing to account for potential sliding and overturning. And we use when the factor effective slope safety factors. The safety factors is influenced by soil proper slope angle and external loads. A higher safety factors indicates a more stable slope conditions. Course specific minimum safety factors for various slope and footing configuration. Designing consideration for footing on slopes, cases, studies, and practical examples. Main the Several fields classes demonstrate the importance of slope factors in footing stability. Failures often result from assignment of slope mechanics. Summary and best practical understanding the mechanics is essential for safe footing designing on slope. Incorporators, slope factors and reinforcement techniques, stability, continuous monitoring and site assignment are key to long-term safety. Friends, thank you.